Hi, welcome back. Today we're going to be looking at time series data. MemSQL is really great for time series data because it has such fast data ingest with non-locking indexes. So you can ingest data while visualizing it without impacting the speed of data ingest. So let's take a look at how we can use time series functions. Let's create a database. We'll use that database. Create a table, and now load some data. Thanks to NCDC for this data. Let's test our pipeline and see how it's ingesting. Yep, it looks like that's going to work out great. Let's start that pipeline. Now, because we created a MemSQL pipeline, as we add more data into this folder, then it will get pulled into place as well. Let's take a look at the data that we've got ingested now. Yep, we've got all of our data. Let's grab a count. 61,000 rows, very nice. All of our pipelines succeeded, that's great. And let's take a look at the locations. We've loaded a bunch of locations, and we have temperature data for each of those locations for the year 2010. So let's start looking at that. Let's do an average of the temperature inside each location. Here's that average temperature for the entire year of 2010. Let's grab an average temperature by day. Here we're going to cast that date into a date object, removing the time, average the temperature, and also get the min and max temperature throughout that day. So here's the average temperature, the minimum temperature, the max temperature for that day. Yeah, it's pretty cold in Chicago. Let's go get the average temperature by week in March. So here we're going to use this time bucket function for 7 days. That will give us a week. And this is a rolling average. So if we were to grab a different starting day, then we would get a different average week. That's perfect. We'll get the average temperature, the min temperature, and max temperature again, but only for those values in March. That's pretty cool. We can see how the average temperature in March gets warmer, but we also see the min and max doing interesting things. JFK is a little bit warmer. Los Angeles is quite a bit warmer, together with Orlando and San Diego. A candlestick chart is really elegant. We can grab the minimum, max, first, last, and this is grouped by date, so that we can put this into a candlestick chart. Let's take a look at that query. We start out with a common table expression where we're grabbing the ranked values. We create this window partitioned by location and time bucket of date. And then we grab the rows, grab all of the rows around this location. We'll then grab the first value and last value, the min value and max value, and the rank, so that we know which one is the value for that day. So now we're going to filter by rank 1 so that we only get one value per day. And then we'll show that time bucket, the date, and the min, max, first, and last values for those values in July. So here's all of the min, max, first, and last values in July. And we can take a look at an example candlestick chart that could be created from it here. Let's look at smoothing. Oftentimes we'll smooth data to avoid inaccuracies in sensors or to eliminate the spikes in the data. Let's look at an average of 3 preceding rows together with the current row. So we'll take that 4-hour window and roll that into each of the values. We'll grab the location, the read date, the original temperature, and then the average temperature smoothed between the 3 preceding rows and the current row. And we'll do this for all of the data in March. So we've got the temperature, and then we've got the smooth temperature. We can see that it's averaging the values before it to get more of a gradual temperature. That's pretty cool. You can grab this script in the description below, and when you're done, here's mechanisms to stop the pipeline, drop the table, and drop the database when you're ready. MemSQL's time series functions are really helpful in being able to visualize time data as you ingest it really quickly. Thanks for watching.